You know that really specific kind of eerie feeling when you open a short video app?
Oh, yeah.
You pause on a video, maybe a cat cooking lasagna, for like 3 seconds. You don't even like it. You just pause.
And suddenly your entire feed is just feline chefs.
Exactly. It's instantaneous.
It has this mind-reading effect. It feels like the app knows who you are right now at this exact second, even if that's completely different from who you were, say, 20 minutes ago.
Right. And as users, we just take that responsiveness for granted. We just scroll. But as someone who looks at systems, that level of engineering speed is actually terrifying.
It's not a static database, that's for sure.
No, we're talking about matching billions of users to billions of items in milliseconds while the users are constantly changing their minds.
It is a staggering computational problem.
Yeah.
And honestly, for a long time, the industry standard tools, the ones everyone learns, they just couldn't handle it properly.
Oh,
They were
yeah.
built for a different era of AI.
Which brings us to today's deep dive. We're going under the hood of the system that arguably solved this better than anyone.
We're looking at a research paper from ByteDance, the company behind TikTok and Byte+.
The paper's titled Monolith, Real-Time Recommendation System with Collisionless Embedding Table.
It's a heavy title, I know.
Yeah.
But the content is fascinating because Monolith, it basically breaks the rules of traditional AI. They looked at how everyone else was doing deep learning, using tools like TensorFlow or PyTorch, and just said,
This doesn't work for us.
we need something faster and honestly a little bit riskier.
So our mission today is to unpack that. We need to understand two main things. First, how they threw out the standard memory management, something called the hash trick, to build a collisionless system.
And second, why they made a really risky bet that speed is actually more important than reliability.
That second point feels so controversial.
Oh, it is. Engineers usually hate the idea of a system that isn't 100% reliable with backups every second. But Monolith proves that sometimes being fast and slightly forgetful is, well, better than being perfect and slow.
Let's start with the basics then, because I think there's a big misconception here. When most people hear deep learning, they picture image recognition.
Right. You show a computer a picture of a hot dog and it says hot dog.
Exactly.
And that's where frameworks like TensorFlow really shine. But the data for a picture is dense,
Dense meaning what exactly?
meaning it's a fixed grid. Think about a 100 by 100 pixel image. It always has 10,000 pixels. The structure doesn't change.
Okay.
You can feed that into a matrix and just crunch the numbers because the computer knows exactly how many inputs to expect. It's tidy.
Okay, so image data is a neat little box. But recommendation data
Is the complete opposite.
Yeah.
It's sparse and it is wildly dynamic. I mean, think about it. If you have a billion users and a billion videos, that's potential interaction matrix of, well, a number with way too many zeros.
Right.
But any single user has only watched a tiny, tiny fraction of those videos.
So if you drew a map of user activity, it would be a massive blank sheet of paper with just a few tiny dots on it.
Exactly. That's the sparsity. But the bigger problem is the dynamism. In image recognition, the concept of a cat, it doesn't change overnight. A cat is a cat.
Sure.
But in recommendation, new users join every second. New videos are uploaded constantly. The vocabulary of the system is just expanding infinitely.
And standard AI frameworks, they struggle with this.
They hate it. They generally assume the number of parameters, the variables the model learns, is fixed. They want to allocate a specific amount of memory for, say, the user category.
But you can't, not if you have unlimited new users.
You'd run out of RAM immediately.
So how has the industry been solving this until now? This is where the villain of our story comes in, the hash trick.
It does sound a bit like a magic show scam, doesn't it?
Yeah.
The technical term is hashing with collision. It's the industry standard workaround.
A workaround for what?
Since you can't give every single user a unique slot in memory, because you'd run out of space, you force them into a fixed-size table using a math formula.
Okay, give me an analogy.
Imagine a massive coat check at a stadium. You have 100,000 fans, but you only have 10,000 hooks.
Okay, not enough hooks.
Right. So the attendant uses a formula based on your ticket number to decide which hook to use. But inevitably, fan A and fan B are going to get assigned to the same hook.
Ah, and that's the collision.
Yes. And in the AI world, that means the system treats user A and user B as the exact same person. Their data gets mixed together. The model learns a shared representation for both of them.
That sounds like a disaster for personalization. If I love horror movies and I get mashed into the same slot as someone who loves romantic comedies, the algorithm's going to think we like, what, Scary
It
rom-coms.
just dilutes the signal, the model gets confused, it learns an average that doesn't really fit either of you. For a long time, engineers just accepted this. They thought, well, collisions are rare enough, and it saves us money on RAM, so it's a necessary evil.
But ByteDance looked at that and said, no, that's not fine.
Right. When you're operating at their scale, collisions aren't rare at all. They're constant. And the degradation in quality was costing them engagement.
If the app shows you the wrong video because it thinks you're someone else, you close the app.
Exactly. So Monolith introduces the collisionless embedding table.
Which implies exactly what it says on the tin.
Every single user, every single video, every single item gets its own dedicated ID. No sharing, no collisions, unique identities for everyone.
But wait, hold on. You just said that would crush the memro. If they give a VIP spot to everyone and the user base keeps growing infinitely, how do they not run out of RAM? Are they just buying all the RAM in the world?
No, and this is the really clever part. They combine a sophisticated data structure with a very, very ruthless bouncer policy. The structure is called a Cuckoo HashMap.
A Cuckoo HashMap. Is that actually named after the bird?
It is. In nature, a cuckoo bird is a parasite. It lays its eggs in other birds' nests. If the nest is full,
It kicks the host's eggs out.
right, to make room for its own.
That is aggressive.
It is. And the algorithm is too. It's designed to maximize space efficiency. It uses 2 different tables and 2 different hash functions. When a new item comes in, it tries to find a spot. If its spot is taken, it literally kicks the current occupant out.
It kicks it out. Where does the evicted data go?
It goes to its alternative spot in the second table. If that spot is also taken, it kicks that occupant out, who then goes back to the first table in a new spot.
So it's constantly reshuffling things.
Constantly, just to make sure the table is packed as efficiently as possible. It's like constantly moving the furniture around to create space.
Okay, so that handles organization, but that doesn't solve the infinite data problem. You still have finite RAM.
Right. For that, they use frequency filtering.
This is the bouncer you mentioned.
Correct. The ByteDance engineers realized something crucial. Not all data is useful. In fact, most of it is just noise. If a user creates an account, watches one video, and never comes back, do you need to store a complex profile for them in your expensive RAM?
Probably not. You can't learn a pattern from one data point anyway.
Exactly, it's underfit. So Monolith has a rule. An ID doesn't even get into the main table until it appears a certain number of times, say 10 times. Until then, it's just filtered out.
That's interesting. So by ignoring the casuals, they save massive amounts of space for the power users.
Huge amounts. It reduces the memory footprint by orders of magnitude. And here's the counterintuitive finding from the paper. This didn't just save memory, it actually improved the model's accuracy.
Wait, really? Usually less data means a dumber model.
Not here,
Yeah.
because that one-off data is usually low quality, it's random. By filtering it out, they prevented the model from overfitting. Basically, they stopped the AI from hallucinating patterns where there weren't any.
So they stop the model from getting distracted by the noise.
Exactly. They also implemented expirable embeddings. If a video goes out of a trend and stops getting views, or a user goes dormant.
Monolith just evicts them from the table. It cleans up after itself.
Yes. It's almost like the system has a biological memory. It remembers what's important and relevant, and it naturally forgets the trivial stuff to keep its mind clear.
That's a great way to put it. And they prove this worked.
The proof is in the data. They ran experiments on the standard movie lens dataset. They compared their collisionless table against the standard hash trick. And, well, the collisionless table consistently outperformed the one with collisions.
It turns out treating people as individuals actually works. Who knew?
Funny, right?
Okay, so they solved the space problem. They have a massive, efficient memory. But we still have the time problem. How does the app adapt in seconds?
This is the shift from batch training to online training.
Set the scene for the old way first. What's batch training?
The traditional method is like a clothing store that only checks its sales once a week. They look at what sold last week, order more of it, and put it on the shelves the next week.
So if a trend starts on Tuesday, everyone suddenly wants red hats. The store doesn't react until the following Monday.
Exactly. In the AI world, you collect data from yesterday, train the model overnight, and push the update to the servers today. The loop takes hours or even days. But in social media, we deal with concept drift.
Concept drift. Sounds like a sci-fi term.
It just means that the underlying data changes over time. Your interests shift. What you liked last month isn't what you like today. Maybe you were into baking videos yesterday, but today you're looking for hiking gear.
And if the model is stuck in yesterday's batch, it misses that shift.
Completely. So Monolith moves to online training. The store manager is restocking the shelf the second someone buys a red hat.
Okay.
They built a screaming engine. User actions, clicks, likes, swipes go instantly into something called a Kafka queue. That's a real-time data pipe.
And this is where it gets tricky, right? Because I might see a video at 9:00 a.m., but I don't like it until 9:01 a.m., or maybe I buy the product 3 days later. How does the system connect the view to the action?
That is the joiner challenge. Monolith uses a Flink joiner to match features with actions. For those delayed reactions, like buying something days later, they use an on-disk key-value store to hold the features while waiting for the user to act.
So it's holding a memory of what you saw in a waiting room just in case you react to it.
Correct. And there's another layer here. They have to use something called log odds correction. You see, people scroll past way more things than they click. There are millions of negatives for every positive.
Right, so the model would just learn to predict user will ignore this every single time.
Because statistically, that's the safest bet. It would be 99% accurate and 100% useless.
I predict you will do nothing. Thanks, AI.
Exactly. So they adjust the math to balance that bias, ensuring the recommendations remain relevant.
Okay, so we have a collisionless table for memory, a streaming engine for speed, but doing everything in real time sounds dangerous.
It is dangerous.
I mean, if you're updating the brain of the AI every single second, what happens if a server crashes? Or the network glitches? Don't you want a backup? A save game file you can reload?
Reliability versus real time. That is the fundamental trade-off Monolith makes. In a traditional system, you update the model slowly and save snapshots, backups, constantly.
Right. If something breaks, you just reload the save from 10 minutes ago.
But Monolith is updating massive models, terabytes in size, across thousands of servers. Saving a snapshot of that every few minutes would be incredibly expensive. It would slow everything down.
So what do? Just cross their fingers?
Kind of. They decided to treat different parts of the brain differently. This is crucial. They split the parameters into sparse and dense.
Sparse being the user IDs we talked about.
Yes, the specific, fast-moving data. Monolith syncs those roughly every minute. It's lightweight data. User A liked video B. That info gets pushed to the serving servers almost instantly.
And the dense parameters.
Those are the weights of the deep neural network itself. The broad patterns, the logic of the AI, those change much more slowly. Monolith updates those maybe once a day.
So it updates my personal profile continuously, but updates its general understanding of the world daily.
Correct. But here's the really risky bet. They only snapshot the training servers once a day.
Once a day. So if a server dies at, say, 11:000 p.m., they lose the whole day's work.
For the users on that specific server, yes. They lose the last 24 hours of learning for them.
That sounds like a disaster for an engineer. Oh, sorry, we lost today.
It sounds scary, but look at the math. They calculated that with a typical hardware failure rate of, I think, 0.01%, losing 1 day of data for that tiny fraction of users is a negligible loss.
Oh, I see. It's a utilitarian calculation.
It is. The benefit they get providing real-time, minute-by-minute learning for the 99.99% of users on healthy servers massively outweighs the cost of the 0.01% who might experience a slight amnesia in the algorithm.
They traded safety for performance, and it worked.
It worked brilliantly. They tested this on the Criteo dataset, another benchmark. They compared syncing every 5 hours versus every 30 minutes.
And the faster sync won, I assume?
By a lot.
Yeah.
Real-time online training consistently beat batch training. In their live production tests, the real world, the improvement was substantial.
It's fascinating. It feels like they stopped treating the AI like a textbook that needs to be perfectly printed and preserved.
And started treating it like a living organism. That's a great analogy. A living organism doesn't remember every single meal it ever ate. That's the frequency filtering.
And it focuses on what's happening right now, online training.
Even if it occasionally forgets a detail, that's the fault tolerance trade-off.
So let's wrap this up. Monolith seems to be the architectural answer to how does the app know?
It is.
Yeah.
It succeeds because it respects the nature of the data. It treats sparse data users and items differently than dense data. It gives every user their own space in the collisionless table.
So their unique taste isn't mashed up with someone else's. And it prioritizes freshness. It's not just remembering who you were yesterday, it's learning who you are becoming right now, minute by minute.
Which is why those feeds feel so incredibly responsive. The loop between you act and system learns has been shrunk from days to moments.
It really changes how you look at your phone. It's not a static catalog, it's a mirror that updates in real time.
A mirror that filters out the noise to give you a clearer reflection.
Now, here's a thought I want to leave you with.
Yeah.
We've been praising this efficiency, this real-time adaptation. It's amazing engineering. But if these systems are designed to adapt to our interest within minutes, are they merely reflecting our desires? Or are they effectively trapping us in a feedback loop of the now?
That is a profound question. If the system is so good at giving me what I want right now, does it prevent me from drifting naturally into new, unpredicted interests? Does it kill serendipity by being too perfect at prediction?
If I click on one cat video, and the system instantly decides, okay, he's a cat person now, and fills my feed with cats, do I ever get the chance to discover that I might also like architecture or jazz? It's something to think about the next time you find yourself 3 hours deep in a feed of cat chefs.
It definitely makes you wonder about the cost of convenience.
Thanks for listening to this deep dive into Monolith.
It's been a pleasure.
See you next time.